For years, the industry told us the big engine was dead. They said the future was tiny four-cylinder turbos or pure EVs. But suddenly, in 2025 and 2026, we are seeing a radical shift that defies every prediction. Toyota, the world's largest automaker, Mazda, the engineering purist, even Stellantis, the owner of Jeep and Ram, they have all decided to resurrect an engine design we thought died in the 90s, the Inline-Six. This isn't just nostalgia for the old Supra or BMWs. This is a calculated economic decision. Mazda dropped their 3.3-liter turbo into the CX-90 and CX-70. Toyota is powering the new Land Cruiser and Lexus lineup with it. Jeep killed the legendary Hemi V8 for the new Hurricane Inline-Six. But why? Why invest billions in a massive, long engine that is a nightmare to package? The answer lies in a single law of physics and a brilliant manufacturing trick. To understand the secret, forget horsepower for a second. Let's talk about vibration. An internal combustion engine is basically a ticking bomb. The V6 engines we've been using for decades are physically unbalanced. To make a V6 run smoothly, engineers have to add heavy counterweights and balance shafts. That adds weight, complexity, and parasitic loss, robbing the engine of power. Here is the magic of the Inline-Six. Because the cylinders are in a straight line, pistons move in perfect harmony. Piston 1 mimics 6, 2 mimics 5, and 3 mimics 4. This creates perfect primary and secondary balance. The result, an engine so smooth you can balance a coin on it while it runs. Less vibration means less friction, less wear, and most importantly, higher thermal efficiency. In an era of strict emissions, every drop of fuel wasted on friction is a loss. If it's so perfect, why did it disappear for 20 years? Simple. Safety and front-wheel drive. An Inline-Six is long. In the era of front-wheel drive cars, engines had to be mounted sideways, transversely. An Inline-Six simply wouldn't fit. It would poke out the sides of the car. Also, in a crash, a long, solid engine block is dangerous. It doesn't crumple. So how did Mazda and Toyota solve this in 2026? They changed the entire architecture. They went back to rear-wheel drive. By mounting the engine longitudinally, front to back, you get that long hood premium look associated with German luxury cars. Look at the Mazda CX-90. That massive distance between the front wheel and the door isn't just for style. It's to accommodate the length of the engine and complex double wishbone suspension. This shift allowed Mazda to rebrand itself as a true competitor to BMW, not just Honda. The smooth torque and RWD dynamics justify a higher price tag. But building a new chassis costs billions. How do they afford it? This is the genius part. Modular cylinders. Complexity is the enemy. A V6 needs 2 cylinder heads, 4 camshafts, and 2 exhaust manifolds. An Inline-Six needs only 1 of each. Toyota, Mazda, and Mercedes are now using a 500 cc per cylinder strategy. Need a 2.0-liter engine? Put 4 cylinders together. Need a 3.0-liter engine? Just add 2 more to the same line. They share pistons, valves, and injectors. It's the same tooling. An Inline-Six is just a stretched 4-cylinder. This saves millions in manufacturing. Finally, here is the biggest twist. This gas engine is actually designed to save the hybrid. Because the Inline-Six is narrow, it leaves a magic gap on the side of the engine bay. V engines are too wide, leaving no room. This gap is perfect for massive turbochargers, complex catalytic converters for Euro 7 standards, and, most importantly, electric motors. Mazda sandwiches a 48-volt motor between the engine and transmission. It kills turbo lag instantly. Toyota uses that space for complex hybrid systems that keep the engine running at peak efficiency. It creates a flexible platform. It runs on gas today, hybrid tomorrow, and potentially hydrogen combustion in the future. We aren't seeing a step backward, we are seeing the survival of the fittest. While everyone else was downsizing, these engineers realized that right-sizing was the answer. The result is vehicles that are smooth, powerful, and surprisingly efficient. This is the mechanical renaissance before the electric takeover. So, the question is yours. Do you prefer the compact complexity of a V6 or the silky smoothness of the Inline-Six? Let me know in the comments, and don't forget to subscribe.